All right, let's jump right into this explainer. Welcome back, BCBA candidates. Today, we're tearing into the 6th edition test content outline, specifically going after those incredibly tricky measurement and experimental design questions you're bound to see on test day. We're taking a highly analytical, laser-focused approach here because we want to make absolutely sure you don't fall for the classic traps that literally cost candidates their passing scores.
So here is our game plan for today. First, defeating exam traps. Second, the duration IOA illusion. Third, mastering baseline logic. And fourth, decoding progress metrics.
Okay, part 1, defeating exam traps. Let's kick things off with a foundational warning about how these exam questions are actually built. The creators, they operate on a really specific problem solution framework. And they absolutely love to use macroscopic totals to trick you into missing critical data distortions. So I need you to drill this rule into your head. You have got to look past the surface data. If you see a scenario offering mathematically perfect data right out of the gate, honestly, assume it's a trap. Because let's be real, human behavior is never perfectly clean, right? Falling for the illusion of pristine session totals without checking the underlying clinical reality will instantly cost you points. You just have to be sharper than the surface level math.
Moving right along to Section 2, the duration IOA illusion.
Let's zoom in on continuous measurement systems. And actually, let's simulate a little exam pressure right now. Picture this. A clinical supervisor is evaluating 2 observers. They're both tracking a client's repetitive pacing across a 60-second observation window. Observer 1 records that the total duration of the behavior was exactly 30 seconds. And Observer 2, they also record a total duration of exactly 30 seconds. So, a simple total duration IOA calculation gives us a mathematically perfect 100% agreement. Would you mark this down as reliable and just breeze on to the next question? Well, if you said yes, you just fell right into the trap. Check out the raw interval logs. They completely shatter that 100% illusion. Observer 1 recorded the behavior occurring continuously from second 1 to second 30. But Observer 2 recorded it from second 31 to second 60. You see it, right? They never actually observed the behavior happening at the exact same time. Total duration IOA completely fails to confirm that observers track the exact same instances of behavior. It kind of treats observers as being in perfect sync, even when they're tracking entirely separate episodes, which just creates this massive data artifact.
So what's the microscopic fix here? You've got to use precise clinical solutions to capture the whole story. First up, engineer mean duration per occurrence IOA. Second, if a client's behavior varies wildly in length, say it jumps from 2 seconds to 15 minutes, you absolutely must pair frequency with duration per occurrence. You need to know both how often it happens and exactly how long each episode lasts. And finally, if you're ever forced to use a discontinuous interval system for a really high-rate behavior, shrink your observation intervals way down to 5 seconds. This kills that systematic distortion and stops the data from artificially overestimating the behavior. Give these metrics the exact precision they demand.
All right, Section 3, Mastering Baseline Logic.
On the exam, you are absolutely going to face scenarios testing your ability to spot exactly how to establish a definitive functional relation between an intervention and a behavior. You really need to know precisely where baseline logic thrives and exactly where it completely breaks down in practice.
This brilliantly illustrates the logic behind the classic A-B reversal design. First, you build a stable baseline. That's your prediction. Next, you introduce and then remove the intervention to see if the behavior reverts. Boom, that gives you verification. Finally, by reintroducing the intervention in that final phase, you achieve replication. It's the gold standard of experimental control because it literally proves you can turn the behavior on and off at will. It establishes internal validity and completely rules out pesky variables like history and maturation.
But hey, watch out for the clinical traps. You absolutely cannot safely withdraw an intervention just to verify experimental control if doing so violates practical or ethical boundaries. Think about it. If you're teaching an irreversible learned skill, like reading or tying a shoe, you obviously can't simply unteach it to return to baseline, right? Likewise, if the target behavior is severe self-injury or highly dangerous, withdrawing an effective treatment poses a massive danger to the client. You have to navigate these limitations super carefully on the test.
Which brings us to Section 4, Decoding Progress Metrics.
The exam creators really love testing your ability to measure not just if a behavior is accurate, but how efficient your teaching actually is. Consider this scenario. An educational consultant is comparing two different prompting hierarchies, most to least versus least to most, to teach a student how to activate a communication device. How do you track the exact runway required for takeoff? How do you know which method is truly the most efficient?
Now, if you just glance at summary percentage scores, they might seem super impressive. Like here, on Monday, the client scores 100%. On Tuesday, they score 90%. But hold on, small denominators drastically distort clinical reality. By giving equal weight to unequal sample sizes, percentages completely mask the true volume of learning opportunities presented. A 100% score on a day with only 2 trials is absolutely, fundamentally not the same as a 100% score on a day with 20 trials.
And this brings us to the specific clinical fix, Trials-to-Criterion. I like to think of this as the true price tag of your teaching. Instead of relying on raw accuracy percentages, it literally counts the actual number of response opportunities you had to expend to reach a predetermined level of mastery. Basically, it evaluates the true cost of the instruction.
Capturing the exact number of trials instantly reveals the superior, lower-cost method. Look at this. Method A required 45 trials to hit the goal of 3 consecutive errorless sessions, while Method B took only 12. So if the exam ever asks you to evaluate which intervention costs less in terms of clinical time, Trials-to-Criterion is always your answer.
As we wrap up, I want to leave you with this golden rule. Discriminative mastery is what passes this exam. It's not just about memorizing definitions, it's about spotting those mathematical illusions. Because ultimately, if you can't see the true reality behind the data on a test, how will you see it when a real client's progress is on the line? Keep studying, stay sharp, and we'll catch you in the next explainer.